Apparently I do musical sorting algorithms now. Hi, I'm Northwest Wind. This video is about knife sort, a working sorting algorithm that sorts based on MIDI music. I have posted a demonstration of that using Black Knife from Deltarune chapter 3. This video is the explanation part. It took me a while to come up with this one, and it's roughly based on a suggestion by a commenter on one of my previous sorting algorithm videos 2 months ago. Sorry I don't remember your name, but I will hopefully find it in post. So anyway, what is knife sort? It looks like knives! Just kidding. To concisely summarize this algorithm, I call it budget merge sort. Merge sort is a cool algorithm that splits the array into subarrays until it can't be split anymore. Then it merges the subarrays and sorts 2 of them at a time. Keep merging until you get the full sorted array. This strategy is called divide and conquer and can make pretty fast algorithms. Knife sort functions similarly to merge sort, where it splits the array into subarrays and merges them again after sorting. However, it doesn't split the array all the way down to atomic size, because otherwise the music is not going to play a part in this. In order to make the algorithm actually run based on the music, we are back to our good old friend, bubble sort. That one commentator is gonna be so annoying. When an array is split, the notes are applied on every subarray. For every index it hits, it checks if the previous element is larger than itself. So if so, they swap, and just like merge sort, we still have the merging part. It will sort 2 subarrays into one bigger array. Once again, this is available on my website. The way I implemented the splits and merges is that they are user controlled. Press C to split the array and X to merge them. Oh, and the sword effect, it's built in. Yep, I have way too much time. Anyway, let's move on to the big old question. Literally, what is the time complexity of this algorithm? Best case scenario, it's O(n) log n, as I have established that this is just a budget version of merge sort. On an average case, it's just multi-threaded bubble sort again. So it's about O(n) squared over p, where p is the average amount of subarrays. Though I'm not quite sure if it's actually n squared, since it's only guaranteed to hit every element at least once after one full soundtrack playthrough, so maybe it's n cubed. The worst case, however, it wouldn't converge. If the array never splits, it's unlikely that the notes will hit every element. And if you don't read every element at least once, you can't sort the array. This actually shows the main challenge of coming up with a musical sorting algorithm. How do you hit every element in an array with arbitrary length using a finite amount of nodes? The previous algorithm, revolve sort, solves this by rotating the array into the nodes. It also looks really cool. But for knife sort, some in-between nodes will definitely be skipped if the subarray size is larger than the amount of pictures in the soundtrack. So with that in mind, if you have any suggestions, please do let me know. I may try to implement them if they are interesting enough. And if you are interested in my implementation, you can check out the code repository. This is still human coded, by the way. Anyway, that's all I have for this video. Thank you very much for watching. I hope you have a good day, good luck, and goodbye!